Okay, so I want to do this exercise, which I think is from a textbook. It says the graph of the derivative of a function f on the interval -4 to 4 is shown. Answer the following questions about f, justifying each answer with information obtained from the graph of f prime. Okay, on what intervals is f prime increasing? So f prime is increasing. Since we're looking at f prime is increasing on this interval here and on this interval here. Okay, so we're going to say it's increasing on the interval -2 to 0, and then from 3 to 4. Now, I'm not really sure what a justification would look like there. I mean, you're just looking at the graph. On what intervals is the graph of f concave up? Well, the graph of f is concave up precisely when f prime is increasing. So this is kind of just leading you into the reasoning in part B. So you're going to say the same thing. It's concave up, right? F is concave up. I'm just going to write that first. F is concave up when f prime is increasing. Okay, which occurs on the interval we literally just looked at above, right? At which x coordinate does f have local extrema? So local extrema, of course, we mean maxes and mins. So by the first derivative test, it's going to have local extrema when the first derivative changes sign. Okay, so this should occur, this occurs, or these extrema occur whenever f prime changes sign. Okay, you don't have to say by the first derivative test. I'm going to do that anyway. You don't need to reference the test. Your reasoning just needs to be good. By the first derivative test. Okay, and when does f prime change sign? Well, it's going to change sign, I think, just at 1 there, right? It doesn't change sign at -2 because it's positive and remains positive. So we'll just say which occurs only at x equals 1. What are the x-coordinates of all inflection points of the graph of f? So an inflection point, right? An inflection point is where a graph changes concavity. Now, the thing you've got to be aware of is that you're not going to get credit on a question like this unless your reasoning relates to the graph you're given. So you have to say there's an inflection point whenever f prime changes from increasing to decreasing or vice versa. Okay, in other words, my understanding of an inflection point, given that I'm looking at the graph of f prime, yes, it's when it's when the function f changes concavity, but we're not looking at f. So like your justification has to be based on what you're looking at. And we're looking at f prime. And so an inflection point is going to happen right here at 0. It's going to happen right here, and it's going to happen right here. Okay, I'm just going to write IP. Those are all inflection points because that's when f prime changes from increasing to decreasing or vice versa. So let's just say which occurs at x equals -2, 0, and 3. And so I didn't even mention the second derivative. And again, that's because the College Board expects you to reason based on the graph you're given. And so we've got like 3 ways of understanding concavity. One is about how the graph relates to the tangent line. If just to sneak up to a different example, like here, right? I was talking about the tangent lines and how the graph relates to them. That's if you're looking at the graph of f. If you're looking at the graph of f prime, notice inflection points happen when f prime changes from increasing to decreasing or vice versa. And if you're at the level of the second derivative, your reasoning would have to say the sign of the second derivative determines the concavity.